Hi, I will be presenting on my final year project, which is about face recognition under spoofing attack, supervised by Dr. Razvi Duman. So we will be seeing the agenda that there is an aims and objectives, the review of architectural system, and then there will be a project demo, a video of the project demo, which will show training of user datasets and the anti-spoofing um, algorithms, followed by face recognition. The anti-spoofing algorithms are eye blinking, random actions, and lip movement, respectively. So in the aims and objectives, we will see that when the user first enters the system, he will have to register himself. He will enter a name and then capture his face images and then train the face images for face recognition. After face recognition and after this training of the images, the user can then proceed with training with anti-spoofing algorithms. First being the eye blinking. The eye blinking algorithm will use several data sets of opened and closed eyes and has already been trained and used in the model in the system. This model uses that the system uses, it will predict whether the user is blinking or not. If the user is blinking, the liveness is successful. Otherwise, it is unsuccessful and displays fake. Next is the random action liveness detection. In this random action liveness system, it uses three main categories of tasks. That is emotion detection, profile detection, and finally eye blinking detection. However, in this eye blinking one, it does not use CNN as in the previous one. It uses eye aspect ratio to determine whether the eye is blinking or not by making use of a shape detector. Then for the profile detection, it also uses a shape detector and determines whether the user has turned right or left. And finally, the emotion detection has a pre-trained model of whether a user is surprised or angry or even happy. And finally, the lip movement detection, liveness detection, uses a shape detector also to detect the position of the lips and predicts whether the user is speaking or not. If the user is speaking for some time, then the liveness is successful and displays and proceeds with face recognition. So this is a architectural system, a simple architectural system diagram of the system. That is, the user just has to come in front of the camera and detects his face, performs the liveness detection, whether eye blinking, random actions, or lip movement, and if it is successful, it proceeds with face recognition. Otherwise, it will display liveness failed or just stops the program. So now we will begin the project demo. So now we will be proceeding with the execution of the program as shown by using this command python app created py on the terminal. I will assume that I am using this application for the first time and we'll just add a user. I will enter my name and the next window will just allow me to capture the dataset that the face images of myself and then create a model for face recognition. I am using Local Binary Pattern Histogram algorithm for face recognition. So I will be capturing 50 pictures of my face as shown. There you go, I'm capturing about 50 images of myself. and the number of images captured is 51. We'll now train the model. It has been trained. So before proceeding with full face recognition, we'll just show that the captured data has been saved in the HPAC folder. There you go. Each time any user is entering the system and being added, it will be displayed, it will be stored in the name that she or she has given. And after it has been trained, the folder, it will save it in the HPAC underscore classifier.xml. Is the name given underscore classifier.xml. Now we will be looking at the face recognition algorithm, which performs anti-spoofing um, first before face recognition takes place. There are three algorithms, three systems, mainly eye blinking, random actions, and lip movement. We'll look at the first one, eye blinking. It will detect the user's eyes, and whenever their blinking is detected, it will display real with the user's real name next to it. However, what might happen when using the eye blinking anti-spoofing by using a still image, we'll just find it out. So it doesn't recognize and says fake. But when I will be in the frame and I start blinking, it recognizes me as being real and displays my name. So next we'll be looking at the random actions, anti-spoofing, and then face recognition. It involves the user to perform a task asked by the system, which will be random, and then face recognition will be performed. Upon successful task fulfilled. For example, here, first task is for the user to act surprised, smile, and right. Once it's successful, the user can perform face recognition as shown. When I close the system, it will just say that I'm a valid user, welcome. So what would happen if the user does not perform the liveness detection correctly? So we'll just see how it works. Or if the user just show a portrait or even a video, for example, since the actions are random, for example, right now it says turn right, I'm going to turn left, and it does change the next task, and now after some time it just says liveness failed. If the user would use in photos or random actions videos as such, it won't work and will display liveness failed. And finally, the last one would be on lip movement, which uses the shape predictor library to locate the lips, and whenever the user is speaking, it detects that it is speaking. As you can see, whenever it's speaking, displays speaking. After sometimes it will perform face recognition as shown. And that's it. And now the last part is for showing the interactions using the app just by going to the go to home page. We'll just go to add the user as in the beginning. And what if the user had already used the application before, it will display all those who have already registered, that is, had their um, name and pictures taken, and just goes switch from previous to another window. I'll show you can easily do the uh, anti-spoofing and face recognition. So So now we will finally proceed with the summary of the comparison of free anti-spoofing system with the random action being the most robust. And finally, the face recognition used is local binary pattern histogram. If it could be more powerful and more accurate by using other face recognition algorithms, for example, dlib database, and by making use of the database itself to store all the data of the system would be a much greater help. So this is it for the project. Thank you for your attention. Bye.